All right, let's dive in. Today, we're going to talk about the story of how we handle the massive, nonstop flood of data that basically powers our entire world. It's a really cool story of innovation, and it's all about three key ideas: Lambda, Kappa, and Delta, and this constant hunt for faster, better insights.
So first things first, why is everyone so obsessed with real time? I mean, think about it. Just a handful of years ago, if you could process your data once a day, you were doing great. Now, if it's not instantaneous, it feels ancient. For businesses today, this isn't a nice to have anymore. It's absolutely critical. Like a bank needing to spot fraud the second a transaction is made, not hours later. That's the world we live in now.
And this chart right here just lays it all out, doesn't it? The old way of doing things, batch processing where you could have hours of delay, it just doesn't work for so much of what we do now. Just look at that column on the right for IoT systems. We're talking about these continuous, crazy fast streams of data where you need answers in sub-seconds. Whether it's fraud detection or managing millions of smart devices, decisions have to happen in the blink of an eye.
And that brings us right to the heart of the matter, the core challenge that engineers had to tackle head-on, the real-time data problem. The simple fact was that our traditional systems just weren't built for this data fire hose, and that was causing some serious headaches.
Here's the bottom line. Classic batch processing gives you stale data. It's kind of like trying to get around a new city using a paper map printed last year. Sure, it's mostly right, but you're going to miss all the new roads and all the traffic. In today's market, that kind of delay can literally make or break a business. These older systems just can't keep up with the constant, high-speed data that's coming at us from all sides.
So how in the world do you solve that? Well, the first big attempt was this really clever but, let's say, complicated pattern called the Lambda architecture. It was a groundbreaking idea that tried to give us the best of both worlds.
So, back in 2011, a guy named Nathan Mars came up with this. Lambda was all about handling huge amounts of data by, not choosing between speed and accuracy. It basically tried to do both at the same time, using two completely separate paths to process the data, one that was slow but super thorough, and another that was fast but maybe a little less perfect.
Okay, let's use an analogy here. Think of this diagram like a restaurant with two kitchens. You've got the batch layer, that's your gourmet kitchen. It's slowly cooking up this perfect, incredibly detailed meal using all the data from all of history. It's super accurate, but it takes a while. Then you have the speed layer. That's the fast food counter, slinging out real-time data the second it comes in. It's fast, but maybe not as complete. Then, the results from both kitchens get combined at the end in the serving layer to give you the full picture.
Now, here's where it gets really interesting, the trade-offs. On the one hand, Lambda is an absolute powerhouse. It's fault-tolerant, it can scale like crazy, and it's super flexible. But, and this is a big but, it is a total beast to manage. The biggest weakness, the one that drove everyone nuts, you had to write and maintain two completely separate code bases to do the exact same thing. Not only is that incredibly complex and expensive, but it's a breeding ground for tiny, hard-to-find bugs and mismatches between the two data paths.
So all that complexity with Lambda got engineers thinking, wait a minute, what if we could do all this with just one path? What if we could make this whole thing way, way simpler? And that one question led to the next big leap in this story, the Kappa architecture.
This quote just hits the nail on the head. See, the problem with Lambda wasn't just that it was annoying to have two code bases, it was a fundamental flaw in the design. Having to write, test, and debug the same logic in two totally different systems was a massive engineering tax and just a recipe for errors. And so, in 2014, Jay Krebs, who actually co-created Apache Kafka, came forward with the Kappa architecture, and the idea behind it was so simple, it was radical. Get this, just throw out the batch layer, the whole thing. In the world of Kappa, everything is a stream. Period.
So let's go back to our restaurant analogy. Kappa is like having a single, super modern, hyper-efficient kitchen. It handles every single order, whether it's for right now or a request about something from last year, in one continuous, beautiful flow. There's just one path. Real-time data and historical data are handled by the exact same system. It just reads the data stream from different starting points.
And wow, when you see them side by side like this, the difference is just crystal clear. On the left, you've got Lambda's complicated two-layer mess, and on the right, Kappa's clean, elegant, single pipeline. You can literally see how much simpler life gets by just ditching that separate batch layer.
Okay, let's break this table down, because the benefits here are huge. Look at code maintenance. You go from two code bases down to one. That's a game changer. Operational complexity gets slashed because everything is unified. And this isn't just about making engineers happy.
This translates directly into real business value. Faster development cycles, way easier maintenance, and a whole lot fewer bugs. But of course, the story doesn't stop there. In the world of data, things never stand still. And that constant evolution led to the next wave, the Delta architecture, an approach that tries to bring all these ideas together in an even cleaner way. This timeline really helps put it all into perspective. You see the whole progression, right? Lambda in 2011, tackling the first big data problems. Then Kappa in 2014, cleaning up Lambda's complexity. And then, more recently in 2019, Databricks introduces something called Delta Lake, and that becomes the foundation for this next evolution, the Delta architecture.
So, what is Delta? Well, it's really the next attempt at getting the true best of both worlds. It creates a single, unified pipeline that handles batch and streaming data seamlessly. It does this with a clever trick. It basically treats a stream of data as just a series of tiny, super fast batches. The result is what people now call a lakehouse. You get the massive scale of a data lake, but with the reliability and data quality you'd expect from a traditional data warehouse, all rolled into one simpler system.
So after this whole journey through Lambda, Kappa, and Delta, we land on the million-dollar question. Which one should you actually use? And the answer, as it almost always is in tech, is it depends. Okay, here's a simple way to think about it. You might stick with Lambda if you've got a really complex, older system that has these very separate, heavy-duty batch jobs that have to run alongside your real-time stuff. Kappa is perfect for modern apps that are built from day one to be stream first. Think IoT platforms or real-time analytics dashboards. And Delta? That's really becoming the standard for building a new, unified, future-proof data platform. That lakehouse we talked about that can handle both kinds of work without all the old complexity. So here's the most important takeaway. There is no single best architecture. The goal isn't just to chase the newest, shiniest thing. The goal is to really understand these trade-offs and pick the approach that actually fits your team's skills, your business goals, and the unique challenges of your data.
So we've seen this incredible progression, right? From the two complex paths of Lambda to the single elegant stream of Kappa to the unified lake of Delta. It's all been a constant drive to simplify how we deal with incredibly complex data. And that just leaves us with one final, really exciting question. As data gets even faster, and as AI demands even more from our systems, what brilliant simplification comes next? Thanks for tuning in.